Hello, my name is Salim, and today we're going to expand our knowledge on how to name organic compounds with multiple functional groups, as well as the functional groups that we haven't learned in this course. We will also do some example problems and learn a real-world example and its IUPAC name. But first, let's go ahead and remember what nomenclature is. The purpose of the IUPAC system of nomenclature is to create an international standard of defining compounds to promote interaction. The goal of the system is to associate each name with a unique structure. IUPAC nomenclature is based on naming a molecule's longest chain of carbons, whether in a continuous chain or in a ring. All deviations, either multiple bonds or atoms different than carbon and hydrogen, are shown by prefixes or suffixes with respect to a specific set of priorities. Before we get into the complexity of naming, let's quickly recap what alkenes and alkynes are. They're basically simple hydrocarbon chains lacking functional groups. Alkynes are the simplest organic compounds. They have only single bonds between carbon atoms and are called saturated hydrocarbons. On the other hand, alkenes have at least one carbon-carbon double bond, whereas alkynes have one or more carbon-carbon triple bonds. Additionally, alkenes and alkynes are called as unsaturated hydrocarbons. Here is the expanded functional group list, most of which we haven't covered in this course. It's arranged in a way that the one on the top has the highest priority and the one at the bottom has the lowest priority. You can find the prefixes and suffixes of each functional group except for acid and anhydrides. Keep in mind that alk in the prefix represents the number of carbon atoms in the root carbon chain. Additionally, you can see the structure of each functional groups. We will recognize some of them in the next slides when we do practice questions. There are some functional groups that do not have their own suffixes. For example, the groups on the slide are not considered in the priority list. They're always substituents and get a prefix. In the ultimate name, they are merely placed in an alphabetical order. For example, look at the alkoxy example, which shows that the longest carbon chain is 2. Now look at the methyl group in the beginning, which is considered as a substituent. Now that we have identified the longest chain and substituent, let's name this compound. Since the oxy group is placed before the core name, this compound is named as methoxyethane. Now please pause the video and take a look at other examples too, but don't get too caught on it because we will be exploring the rules detailedly in the next slide. Now that the functional groups and their substituents have been observed, we can apply a simple modified rule to name all compounds. In step 1, first find the highest priority functional group. Determine and name the longest continuous carbon chain that includes this group. In step 2, number the chain so that the highest priority functional group is assigned the lower number. In step 3, determine if the carbon chain includes multiple bonds. If there is double bond, replace ANE with ENE for an alkene or YNE for an alkyne. Designate the position of the multiple bonds with the number of the first carbon of the multiple bond. However, if the compound includes functional groups, indicate by prefix or suffix. For example, carboxylic acid, aldehyde, ketone, alcohol, amine group, and so on. Replace the last E with the suffix of the highest priority group and include its position number. Lastly, indicate all substituents and functional groups on the molecule of lower priority with a prefix. Put the prefixes in alphabetical order before the root name with correct position numbers. Well, there's one more rule in the presence of multiple functional groups that needs to be clarified detailedly. We will determine which suffix we need to use out of all the functional groups on the molecule. Let's do this with an example. If you have a molecule with, let's say, a carboxylic acid and a ketone, you check the priority list that was presented in the previous slides. The functional group with the highest priority will be the one which gives its suffix to the name of the molecule. And the functional group that is lower in priority will only be written by their prefixes with no association with the parent name. So in the first example, the suffix of the molecule will be oic acid, not ONE, because carboxylic acid are given higher priority. Now pause the video and work on other examples for your practice. Do not forget to consult the priority table. Now let's take a look at this compound and try to figure out its IUPAC name with respect to the naming rules we have just learned. First things first, we identify the highest ranked functional group. This will change the core name by adding an oic acid at the end. Secondly, we find the longest chain with respect to higher to lower ranked substituents. The longest chain in this case is 6, so our core name is going to be hexanoic acid. Now we identify the substituents. We have a probably group on carbon 2 and 2 methyl groups on carbon 3. And we have an amino group on carbon 6. We will alphabetize our substituents followed by the core name at the end. Once we alphabetize it properly, we get the following name for this compound, which is 6-amino 3,3-dimethyl 2-propyl hexane 1-oic acid. Let's go see another example. In this example, we first determine the highest priority functional group, which in this case is the ester. Then we determine the continuous longest carbon chain, which starts from the left of ester group up to hydroxyl group. Therefore, the parent name would be hexanoate. Note that there is a methyl group on the left side of the ester group, and it's considered as a substituent. Now we determine other substituents. There's an aldehyde on carbon 4. However, the carbon of the aldehyde is not part of the parent chain, so it would be incorrect to call it OXO group. Instead, we call it formyl. There is also an hydroxy group on carbon 6, and we alphabetize these substituents where methyl group comes first, and then formyl, and then lastly hydroxyl. Thereby, we get the name methyl 4-formyl 6-hydroxyhexanoate. Now, we're going to explore a real-world example. Sulfonamide is the active ingredient of all kinds of sulfa drugs, antibiotics, that are sold over the counter. Sulfonamides work by preventing the growth of bacteria in the body by inhibiting PABA incorporation into dihydropertoic acid, which in turn blocks folate metabolism. Let's identify the IUPAC name of this structure. There are two functional groups on the molecule, sulfonamide and amine group. With respect to the priority order of functional groups in the previous slide, sulfonamide must be given the priority. Thus, the functional group is sulfonamide attached to an aromatic ring. Now, we must identify the parent chain in order to determine the parent name. Since sulfonamide, which is the principal functional group, is located on the benzene structure, the benzene acts as the parent chain. Thus, the core name would be benzene sulfonamide. Since benzene sulfonamide is the parent chain, we must count the parent chain starting from sulfonamide, as it's the highest priority functional group. Lastly, we identify the side chains with its location, which is the amino group. However, since there's another group in higher priority, the amino group will be named 4-amino. If we had more side chains, we would need to arrange them alphabetically, like in the previous examples. But there's only amino group present here, so we don't need to. Therefore, the IUPAC name of this active ingredient in sulfa drug is 4-aminobenzene sulfonamide. Thank you so much for your time. Have a great day.